You always do that. And then I put in my new data.
And then you
and
put in your data. Yep. Over on the right-hand side, under environment, you'll see that you now have a new field called DF. It identifies the number of observations, the number of variables that you have.
Okay.
Yep. There's a lot of extra information, and it's not something to memorize, but you do start to get used to that field and you find a lot of information there. So line 20 through 24, what is that going to do for you?
It's going to identify types or things as factors instead of numbers.
One, yep, that's going to be 22 through 24. What's 21 doing for you?
Telling you which things you're going to look at.
Okay, what does DF stand for?
The what?
What is DF? What it says DF equals DF. DF equals read underscore CSV. What's this DF thing?
I have no idea.
Yep, good question, good answer. It's the name of your matrix. So it's now your data set, where in the Excel file, it's called demers underscore 2110 27 underscore CTAC. We've now renamed that as DF. And DF stands for data frame. It's just a common shorthand in R. And I use that same name for everything so that I don't have to rewrite that part of the code. So I can now use this code. I rename my Excel files as DF, and then I could just reuse stuff. Makes it much easier.
Okay.
Okay, so run it.
Here.
You did that. You could do it again. That doesn't matter. But line 20 through 24 is what you want to run.
And
so
you
just hit run at any point. Yep.
And hit run.
Notice over on the right-hand side, under environment, we now have gone down to 4 variables.
Okay.
Selected out the ones that we're interested in. Yep, go hit that blue button. And notice now we have factors. We have factor for location, factor for type, factor for intensity.
Okay.
Okay. Go ahead, run again for summary. And that gives you some very basic information. Shows when you might have some NAs, it gives you intensity, gives you ratios. That all looks very good.
Why is this one there?
Why is location?
Collier County mosquito control.
I don't know. It's in your Excel file.
Oh, it's one of my. And then how did you find the other?
Oh, so go down under, why don't in line 27, let's put another call. Let's do summary. Parentheses, DF, $. Go back inside the parentheses. And let's do location. And then end parenthesis. Go and run that. That shows you all the different names of your groups. Now you want to drop anything that had less than 10 data points. And I gave you some code for doing that.
Copied.
Yep. Okay, go to line 24. We're going to do that as part of our mutation. Go to the end of the parentheses. Let's make a new pipe. So that's the percentage greater than percentage sign.
And what does that do?
It's basically like a plus. It's adding on another manipulation to the data set. So
Okay.
each time we have it, we have DF equals DF plus select plus mutate. We're not going to do a few more. So hit enter. Now hit paste. Okay, so now we have to fill in a few things. We need to change group by and we need to change it the name, which is location. Perfect. And now we need to change filter to the size. So where it says size, we need to change that part.
How?
I just changed the word size to 10, is what I think I remember you saying. Or anything that is, and let's change it to 9, so it's 10 or more.
And then ungroup it.
And then you're going to ungroup it. So now we can rerun line. In fact, rerun line 18. A good habit is to put the data back in, then mutate it again. Yep. And then just hit run again. You don't have to move the cursor. Just hit run. Yep. Okay. Now if we do lines 30 and 31.
Run.
Go ahead. Now you'll notice that there'll be, okay, we've got anything that was less than 10, those entries have been eliminated.
What about these zeros?
They won't be part of the analysis. We've taken them out.
Okay.
Presumably. That's what it looked like it was doing. That's why I was playing with it. That seemed to be right. Okay. The next part is just something to run where all your plots will have a standard format. So you can just hit run. That'll be lines 35 through 49. And you don't have to move the cursor.
You don't have to move the cursor.
Nope. Okay, so that was all put in. So if we scroll down in your script for a bit, this is just setting up what the plot will look like. It's not an actual plot yet. See where the cursor is on line 51?
Yeah.
If you hit run, R is going to go until it finds a line of code, and it will run that line of code. So if you hit run at this point, it's going to read line 51. It's going to ignore it because that's a note. And it knows that because there's a hashtag at the beginning. It's going to skip line 52 because there's nothing there. It will automatically go to line 53. It's going to see a line of code and it will do that operation. It's a line-based program is what it's called. So it does each thing in order that it's presented. So go ahead, run. Oh, okay. Yep, let's go back up. There's one more line of code that we forgot to put in. Go up to line 31. And now hit enter at line 32.
Type in enter.
No, just hit enter. Hit enter on your key, return or enter. Yep, go back to line 32 and let's attach. Parentheses, DF. Perfect. And let's run that. What that command does is it puts the variable names into R. So we don't have to, do you see on line 31, we have DF $, then the variable? It allows us not to do that DF $. It will just allow us to put in the variable without that extra little bit of code.
But we have an error.
That's why we have an error. So let's go down now to line 51. Now we should be able to run. It should run fine. Nope. Oh, yeah. Okay. Yep. This one, I'm going to ask you, why do we have an error? Let's read what line 54 is doing for us. And why do we have an error there?
You're selecting any ratio of 4 to 6 in a location type.
Do we have a variable called location type?
And location type is not found.
Right.
So
Nope, you're doing the right thing. Do exactly what you just did. Nope, go back down to that blue circle. One more up, DF. It's not called location type, it's called location or type. So we have to change that name.
well, location is there. Type is a separate one.
Yep, we changed the variable name last time. So we just need to update your code. Not there. Nope, down. Keep going down, keep going down. The line 54, you don't have a variable called location type. That variable name has to be changed to what it's called. And it's typed with all caps. Perfect. Let's see if we can run it.
You're saying it doesn't matter where you run it from, or it only runs to where your cursor is?
It will, wherever your cursor is, it will run to the next line of code. So skip anything that's not a line of code. Okay, so now why do we have an error in 57 and 61?
Argument 1 is not a vector. An error in data frame X equals X and G equals G.
Mhm.
Imply differing number of rows. There's something wrong with, I can't tell what.
It is the source of more than 90% of errors in code. It's not complicated, but it's very easy to miss. And we just fixed it for line 54, but we have not fixed it for the other two lines of code.
Well, it's here messed up.
Yeah, it's the variable name. The variable name has to be,
Again?
yep.
Yes?
Yep. Now I'll try running both of them. 57 might not work because two keys don't always work, but go ahead and run it. It did work, that is good. And the pairwise mutation should work. Go ahead and run that. Yep, that worked without issue. So can we scroll up and actually look at some of the results?
So we have nothing of significance.
Let's scroll up to the first bit of results.
Oh, that's not right here.
Keep going up, 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 up. Okay, that's the first bit of results. So the ratio by type, the p-value is very large, there's no difference.
So no difference between campus, the golf courses, or any of the, when they're all compiled together as just those three groups?
That's what it appears to be, yep. What a two-key test and what a pairwise test do is it looks at each pair of groups and it compares them. If there's going to be no overall difference, there will be no pairwise differences. So if we scroll down, we have those groups, GCL, GCE, septic, SEP, all of them are the same.
And what's this doing?
The permutation,
Oh, that's that other table.
yep, yep. You have two analyses that do the same thing. Line 57 is a two-key test. That assumes traditional requirements in statistics, normal distribution, equal variances, all of those introductory expectations. Most biological data do not conform to that. Most biological data are not normal. Variances rarely are equal. You know, these are just not things we see in biology. What a permutation test does is the same type of procedure, but it resamples from your data and then randomly assigns them to groups and evaluates how big your initial differences are, the ones that you measure are, to each iterative of this permutated analysis. It's a very powerful and good technique.
And that's this pairwise permutation.
That's a pairwise permutation. So what I would do is let's save that information. So highlight. Yep, highlight the results. Not all the way up, not all the way up. So just the table with the permutative results. So scroll down, keep going down. Yep, just starting from comparison down to 0.7858. And then right there, yep, copy that.
To what? Just a Word document or something?
Nope, nope, we'll actually put it in your script. It's a good place to save things. It'll keep that information together. So go up to line 65. And let's paste over line 65 through 68.
Just Control V.
Yep. Okay. Now we just have to do a little bit of cleanup in the data. So go to line 65, 66, 67, all of them, put a hashtag before the information.
Before the one?
There. Yep. And go up one line starting at 65 and do the same thing. Yep. Now just keep on going all the way through. The hashtag makes it a note. R is not going to read that line. So it's a way where we can save our results and have them accessible right next to the code.
So this is not good for the abstract I just submitted.
Give me 1 second. Are you heading out?
I'm gonna get Chris.
Okay.
So the next thing to do could be to look within San Carlos Park.
There's going to be, so where did this particular question come from? What was the idea behind this?
When we saw not the right one. Wait a minute. What Laurel presented no, that's not the right one either. Sorry.
No problem.
And they presented this, which was their analysis that showed the campus and the reuse were significantly higher than the septic.
Right. So it looks like there's a lot more groups in the Excel file we just analyzed.
Yes.
Okay, so
So this was a single location lake in Cape Coral in an older community that uses septic tanks.
okay,
This was the adjacent reuse community that had stormwater ponds for their reuse.
okay.
This was our campus.
Was it you had two young men last spring. Were they the ones that compared across the campus?
Yes.
Okay, what I remember is that there seems to be a lot of there on the campus, there seemed to be variation among the ponds on the campus. That not all ponds were the same. Do I remember that correctly? Okay. So one of the reasons that we may be seeing no pattern is when you're comparing across types, all that subtle variation is disappearing because you're sort of categorizing everything together and it may not really be appropriate to categorize it together.
Right. And that's why I have the different, so this was their ag and campus. These were their lakes on
Right.
campus. So yes, that's why my spreadsheet also has golf course, lake and effluent separated by, let me see if I can, do I click up here to show you where do I show you my spreadsheet?
Oh, go over where it says DF under environment, all the way on the right-hand side. Let's go down, down. There's that little box. It's actually a little spreadsheet icon. When you hit that, that'll open up a new field.
Okay, so I have locations.
Mhm.
Separated different from type.
Mhm.
So if I look at filter here, how do I do my? So right now what you've done is, how come it's not showing me the way I want to see it?
I don't know what you want to see. I'm so sorry, Nora. What are we trying to show?
I'm trying to show you the different columns.
Oh, go to the Excel file. It's much easier to do it there. You can do it in R, but it's much easier to do it in Excel.
Okay,
And is this a
so
data set?
yes. So what you just did was this column,
Mhm.
campus, golf course effluent, golf course lake, these columns to our 4:6 ratio.
Exactly.
I also have one that's more precise. Okay, so C is campus. CA is within, what's the best way to show you? So these ones are all septic,
Yep.
but they're within the strand of the community of the drainage system called the Calusa strand. And even more specifically, the site is Calusa and Phlox.
Yep.
So let me see if I can show you quickly. How much time do we have? Half an hour more?
Roughly, yeah.
Um, so this is within San Carlos Park, and I'm going to move this over to your side. This is the community of San Carlos Park. Here's Alico
Mhm.
Road. Here's I-75 and 41. This strand is called Calusa or Cypress,
Yep.
and there's 3 locations. This one's called Calusa, and there's 3 locations. Then we have the lakes. This lake surrounded by city sewer. No data on that one. This one's kind of like a lake, and these 3 are called the outfall. So if you go back to the spreadsheet,
Mhm.
you have, what we just did was just this one, right?
Mhm.
I don't know why it's,
Under site, you need
Ah.
to reselect everything.
okay. Yeah, so what we just did was that one, but now I have within it the Calusa strand, the Cypress strand, each golf course independently,
Mhm.
and the lake separate.
Mhm.
And then within that, I also have each individual spot.
Mhm.
So that's how to tease apart whether or not, that's what we did with the FGCU lakes, right?
Mhm.
So
We're
yeah,
gonna take a look at that real quickly. That
I'm sorry?
figure that you showed me in the PowerPoint just a few seconds ago with the FGC links.
I don't understand the comment.
Please show me the figure again that we made last spring with a gentleman about the campus lakes and the variation within that. It was the two gentlemen.
Yeah, I know. I'm just trying to figure out where the heck I put it.
Oh, oh, excuse me.
You'd be glad to come back to campus?
Yeah, it's getting boring at home.
Let's see. Let me really quickly go to my modules again.
Yep, there we go. Okay, so one of the things that's true, that appears to be true, as an example, is not all of the lakes, not all the ponds, not all the systems at a location are the same. They're not. You know, you look at FGCU campus, just as an example,
We
the
have no business aggregating them.
yeah, the outfall, the food forest, and maybe it's Merwin Lake, that one right there. Maybe it's no North Lake. Those are similar to each other, and they're very different than the other ponds. When they're put together, you now have a lot of variation that is probably not appropriate for what they are. So that's one of the things we're looking at data. And if we go back to R, as an example here, and we go back to your script,
Right.
perfect. And scroll up to line 50, 51. Yep, perfect. Analyzing a different variable is very easy from here. You take that exact same code and you just change out what you're looking for. You know, instead of type, maybe you look at location. Or you take that Excel file and you make some adjustments to it. So instead of, like, as an example, just calling it campus, you know, you have campus managed ponds, campus unmanaged ponds, as ways to try to figure out what is going on. One of the things you showed me in your map, which is very nice, is, and it's good data collection, you have sort of a, yeah, if we go back to the San Carlos map, there's a nice way in which you collect it upstream to downstream, where ultimately you would expect the downstream locations to aggregate more of the pollutants potentially. You know, so like in those three along, I think you said it was Cypress. Yeah. The one on the right-hand side should have the fewest amount of introductions. The one on the left-hand side now includes all the population from the right, but then everything else coming in from all the houses and locations. The fact that you have a pond that is surrounded by a septic system and another isolated pond that presumably is not, those are really good points of comparison to try to disaggregate what's influencing the development of these fish.
So how do I do some disaggregation on this?
Well, okay, so let's scroll. Let's go back to the R. Scroll down. Let's actually fix up the remaining part of this code. So scroll up a little bit. Let's actually fix up to the plot. So we have sort of a full starting at 81. We have the old variable names, so those are going to have to be fixed. So instead of location type, it's going to need to be type. And then also on line 5085. Yep. Okay, and then let's go down, just take a look at your figure real quickly, just see how it's going to plot out.
Do what?
I'm just reading the line, just taking a quick look at it. Keeps going down. I want to see now 105 through. Yep. Okay, great. So let's go back up to the beginning of the plot. Beginning of the plot is right there. And let's make yourself a note. Go to line 76, hit enter on your keyboard twice. And then hashtag plot, and then 4 hashtags together. Okay. What that does right there is it creates a little outline for you. In the script, where your cursor is right now, if you go to the top right-hand side of that pane, you can see a series of lines that are going horizontally, and it kind of looks like a little bit like an outline. If you hit that, that is exactly what it is. It is a little outline. Each time you have a line that has a hashtag with 4 hashtags afterwards, it creates a point of reference within your code so you can quickly navigate around. So if you go to ratio type and you click that, now I'll move you up to that section of the code. If you go down to plot and you hit that, now you move you to this section of the code. Where that becomes really valuable is a lot of this is looking through the analysis. So being able to quickly to a point to check something, analyze something. So now we have some basic code to make a plot, and that's all that section is underneath. So why don't we go ahead and run that? Line 83, and again, you can just press run.
Right where I am?
Yep, right where you are. It's gonna look for the next line of code, and it'll run that. This puts in something to the environment. It's basically setting up what the figure will look like. The next line is gonna give us a box plot. We're gonna hit run there. And this is what we see here. Okay, so those are our different locations. It's kind of a busy figure. Each one of those data points is represented by a point. We have our box. We can get rid of things very nicely and easily. If you don't like the data points, go to line 91 through 94. This is, I'm sorry, 91 through 94. That's all about those little data points that show up in there. What would you do to not run that part of the code?
Could put hashtags in it.
Perfect. So put a hashtag in 91, 92, 93, 94.
Do I need to get rid of the spaces?
No, you're fine. Yeah, it'll see the hashtags and it'll be, yep, just won't read it. Remember before when we had the piping, the percentage greater than percentage sign? This
Yeah.
is in ggplot2, which is what we're using here to make figures. It uses a plus sign to do the same thing. So with each line, you get a plus sign. That's just saying do another part of the code. You can go in and run it. And now we get a figure without all of that extra information. So one of the nice things about these is it's pretty easy to add and remove things based on how you want to present. So as an example, right now on the x-axis, you have both the location types, right? But you also have that on the legend on the right-hand side. And we really don't need both of those, right? So line 90 is actually a code to get rid of the legend. It has a hashtag on it. Let's get rid of that hashtag and actually run that line. Okay, now run the whole thing again. And now we get same basic idea, but now we get rid of that redundant information on the side, and it shows us what we want. Make sense so far?
Yeah.
Great. Questions so far with this part?
No.
Okay.
I could have taken this code, copied it taken away the hashtags and kept both the scatter plot and the summary?
Yep, and you can put in those scatter plot points by getting rid of the hashtags in line 91 through 94.
And looking at that,
Now run it again.
there's some trouble here. 'Cause these are probably bad data. For
Oh, you think those
female-
large ones are bad data?
For females to be over 2 doesn't make sense. So probably somewhere in my spreadsheet, there might be some females that were misidentified. Or did we not? I think we selected just females. I thought I had done that.
Let's go to the Excel file. Take a look. This is, you're doing exactly what you're supposed to do with data analysis. You look at things, if it doesn't feel right, you go back. It appears to be only females. And you have some very large individuals.
So these ones here are probably misidentified. Certainly that one is.
If you want to, what we could do is take a look at those. So scroll all the way up, deselect everything. And now select the ones that are large.
Sure seemed like there was more than that on my, see, but it says super masculinized female, and there's not that many of them, so I'm gonna leave it alone because I don't have time to go back and check the figures.
Yep. Do me a favor, go back to column L, because there is another thing that's problematic. Select all, and then go back to column L. Now deselect all. I want to look at that 0. Enter. Those definitely don't make sense. You can't have a 0.
So just delete them?
Yeah, you can delete them.
And that's just delete or clear content?
Do me a favor, because I don't want to delete. Yeah, just delete row. Okay, now once get rid of the filter. Yep. Okay, save it.
Good?
Yep, looks good.
Yeah.
Oh, Lord. Do cancel, let's try something. Say cancel. Go back, just says save. Just hit the save button. Nope, please. Yep, that should work. Go ahead and just say save. It's probably not going to work. We'll try something else in a second. Just hit save. Let's try it. It's probably not going to work. We'll try it. All right, say cancel. In the top left-hand corner, there is the old floppy disk icon. Just hit that.
Yes.
Keep going up. Nope, up. Yep. Okay, there is something going on that's weird. Just go do save type as. Go down to CSV, a little bit further down, comment eliminated, a little bit up. A little bit further up, right there, hit that. Save, replace it. Okay, cancel. We're gonna have to give it a new name. Get rid of the filter. That's actually go back, cancel. Get rid of the filter, so yep. Hit that. Now just go up to the icon on the top, hit save. I do not know why it's going to save as every time. We're gonna have to give it a new name. Save as. Start with the Excel file. Yep, yep, perfect. Perfect, let's go back to your error code, scroll up top, and you have to change line 18. Now you're set.
Run.
Yep.
And
And
it
on the
just
next
goes
line,
step by step. How is it deciding where to stop?
it runs one line. So go and stop for a second so I can actually answer your question. In line 56, we have a command with one bit of information. Give me the summary of fit. In line 54, we're defining what fit is. That has multiple parts. It first says we're going to do an ANOVA. It then defines what the model is going to be, ratio by type. And then there's a comma. In the next line, it defines where the data is going to come from. It's going to come from DF. So the entire thing is set off by those parentheses and it'll run all the way through. In line 56, that line is much more simple. It's just getting a summary of the variable fit. In line 57, we now have a command, the toolkey, we have a parentheses, and we have three different parts of it. We're going to do fit, which is coming from line 54. We're going to look at it by a particular variable type, and we're going to order it in how the p-values are going to be shown up. So it runs the whole thing because it sees the parentheses, then a series of commas until it finally gets a closing parenthesis. And it'll stop after that closing parenthesis.
So keep going.
Yep. Yep. Keep going. Okay. Stop, go and stop, 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 stop. One of the things you'll notice now in the figure is you have no females that have 0 fins. Those females are now gone, and they shouldn't be there. The next line, 107, is going to make the same type of figure. It's just going to make a bar plot. Can you scroll down a bit just so I can look at the code? Do me a favor, put a hashtag in front of line 120. Get rid of the hashtag for line 117. I want to try something. I don't think it's going to work, but we're still going to try it. Okay, in line 123, where it says labs, after the parenthesis where it says title, put a hashtag in front of the word title and in front of the word subtitle. And then, yeah, scroll down a little bit more. Hashtags from 127 through 136. In fact, actually just delete 127 through 136. And then delete the plus after 126. Okay, let's run it. Yeah, I know it's gonna work. All right, do me a favor here, where you see that hashtag in front of the word title, let's delete from there, in front of the word, from the hashtag, sorry. Nope, nope, other way, we're gonna delete from the hashtag through the comma. Nope, move it up, one more row. Yep, delete. Now delete that comma and delete the hashtag. Now go down to the Y and press delete until we get it back by the parenthesis. Okay, now try running it again. Why? Do me a favor, go back up to line 85. Go to run line 83 again. And then hit run. Hit run. And hit run one more time. Okay, so no, we do have an error.
Where is it trying to merge something?
Get rid of line 117. Put a hashtag there. Go and run it. Hit yes. One.
What kind of mean dog is that?
Little cockapoo. Blind as a bat. Well, that's ugly. Great. Do me a favor. Go to line 120. Get rid of that hashtag. Press run. That looks better. That looks better. Okay. Scroll all the way to the top of your code. So actually hit, yeah, and go after where it says GG, sig, if, press comma.
I have no idea where you are.
Line number 5. Line 5. Go to the end, hit comma, then H miss, capital H, M-I-S-C, and lowercase is for M-I-S-C, and lowercase for E-M.
Run?
Yep. Okay. Good. All right. So
We need to disaggregate this
I think you want to disaggregate that. I think you want to disaggregate campus.
and the golf courses.
Right. What you have is now fully functional code for this type of image.
But
It's going to need some more
Only-
analyses.
yeah, only with the last. So that was my prior data. I have to do something here.
With intensity?
No, to select other things,
All right.
right?
So hit save.
File save.
You could just see under where it says the red part, the Gambusia, see a little icon underneath. It looks like an old school floppy disk. Just at that. Yep. Okay, so one of the things that I do a lot, which is what I just heard you say, is I want to re-look at my data or maybe select out different things to use. So run line 18. You guys up?
Yeah.
Okay. Are you guys coming back or what are you guys doing?
No, we're gonna test and wait for funeral.
No, after the funeral.
There's the funeral at 11 and then Davy's house at 1. and-
So we'll see you this evening. Okay. Okay, let's go take a look at TF under environment. So go over to the environment on the right-hand side where it says DF and you have that little blue arrow, hit that. Okay, are there other types of data that you would like to see in your data set based on that original Excel file?
Site first. Site is more disaggregated than type, but not as disaggregated as acronym.
Okay.
Acronym is the most disaggregated,
Okay,
the most granular.
so what do we have to do to lines?
Best to do acronym
21.
first?
What's that?
Would it be best to do acronym first, the most disaggregated?
So if we go to, if you could show me the map again with Cape Coral? No, I'm sorry, with San Carlos? Yep, thanks. I think ultimately, you're going to want to pull out data that answers more precise questions. So as an example, that only compares Cyprus.
Right,
And look in Cyprus, do we see an accumulation
right.
that would be explained by additional influx of endocrine disruptors? I think you're going to want to disaggregate, and I don't know what it is, that pond in the top. If there is another pond that's being directly compared based on different ways in which they're managing those. And right now, all these data are together, and
Right.
it's asking a global question. I don't think you're asking global questions. I think you're asking more narrowly defined questions. So let's go back into the Excel file. Okay. So what I want you to do is just give me Cyprus. Let's start with that. So let's filter out. Okay, so unfilter because we've only got the bottom half. So yep, click that again. Yep. Just select any cell. Okay, now hit filter. Now we'll get everything. Okay, and scroll up. Nope, didn't work again. So unfilter. Yep. Go over to. Oh wait. Scroll down. Scroll down. Scroll down. Okay. Do me a favor. Go to the left-hand side. There's a little triangle that's diagonal pointing down a little bit. In between A and 37. Yep. Select that. Yep. All right. Go to sort. And sort by ID. Yep. We had a few empty rows because remember we deleted some things. That actually may have been why we had some problems. Okay, do me, yep.
See if it'll let us. Yeah, it won't.
There's something really weird.
So now it's there. We have to put it back into R, and you wanted to see what?
Okay, nope, not like this. I cancel. Get rid of that filter. Because you only filter with one column. So I want you to highlight the triangle. Yep. Okay, now hit filter. All right, so what I want is I just want the 3 points along Cyprus. Excellent. So go back up, copy this, open up a new Excel file, paste it. Excellent. Okay, let's save this as Cyprus. Excellent. Okay, and then yep. All right, and in Cyprus, nope, let's go back. There's a logic to these. Let's open up another column.
What do you
Yep,
want?
that'd be a perfect spot. Insert, and what I want is I want the headwater, the middle, downstream. So up, mid, down. Okay, so there's actually here's a way of doing this where there won't, because see, YO is not mid, right? In line number 4, row 4.
Oh, how did that get there?
I don't know, but that's downstream or is that
Yeah.
upstream? And CYP is,
Cypress and oil is up.
okay. So one of the things that I do here, if we could scroll up, make life a little bit easier for you. Highlight everything. So that little arrow, yep, turn 1 to A, yep. Do filter. Select it by acronym. Yep. And then we just repeat that each time. So we now make those all mids. Now go back to acronym. And go back to acronym. Go back to acronym is where it is. We need CP. Perfect. Okay, they all should be there. Do unfilter. Let's just check real quickly, scroll down. Yep, looking good, looking good. Okay, this is saved as Cypress. Excellent, let's go back to the R file. Now here's a nice little trick. All your code is gonna work. We need to make a small little adjustment. Go to save, go to file, and let's do save as. We're gonna save it as a new script. We're gonna put it in the code and it's gonna now just be Cypress. Perfect. Changed line 18. And what I like to do is I would actually just encourage you to delete the file name because this is gonna be much easier for you. Yep, delete that. Oh, yep, perfect. Delete. Now hit tab on your keyboard. Go to data. Hit tab again. And now let's pick the right file. Perfect. That just keeps me from making typos and there's other things that just could be very frustrating. Run line 18. Okay, now we have to make a few little adjustments here.
You only got 2 minutes, Billy.
That's fine. Where the big one is within. That's the one that you want. So in line 21, put comma, and then let's add within.
After intensity?
Sure. And perfect. And then go down to line 24 after the word intensity. Go in between the two parentheses. Hit comma, enter. And now let's do the within equals as factor. No, within. Yep, perfect, perfect, perfect. Okay, so now we're on line 18, or I'm sorry, we're line 20 through 28. Yep, run. Yep, hit Hit summary. Yep.
run.
Yep. Yep. Hit run again. Lovely. Hit run again. Lovely. Hit run again. Okay, now let's update our code. On line 55, how do we need to update it? And we got 15 minutes.
Is that it?
Nope, line 55 and line 62.
Right here?
Yep. It's the same issue each time. And now line 55. Okay, go ahead and run. Okay, go and stop. In Cyprus, do we see a difference between the three locations?
It looks like it.
We absolutely do. We have a low p-value. There is a difference. We don't know what the difference is yet. That's where the plot becomes valuable. That's where the postdoc does become valuable. But there is clearly a difference. Go and run lines 68 and 62.
So just keep hitting run.
Twice. Yep. And one more time. Okay. This is the one I care about the most. And what I want you to do is the same thing we did before. Let's copy out the results. They're down in the console. And let's put those line of results. No, not all of it. Go down.
Just
Yep.
the pairwise.
Yeah, down, 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 a little bit down further, a little bit down further. So from
Down.
comparison through the numbers.
Ah,
Yep, perfect. Copy. Now get rid of line 66 through 76. Not that one. 66 through 76, the results. Yep, paste. And now put those hashtags. Okay, this is telling you that downstream and mid are different. Down and upstream are different, and possibly mid and upstream. You know, so let's make a figure. Change line 77. So you're actually going to analyze ratio by within. And then line 81.
that one.
Yep. All right, let's run. Go and run again just so we can see it. Okay. That's weird.
But what's my sample size is much smaller here.
They're smaller. They're smaller. You have enough sample though to describe the patterns.
So I have the most masculinized at my upstream location,
Yep. Yep.
most supposedly, conceivably, the most concentrated water.
Yep.
Water flows from upper right to lower left.
Yep. Go scroll down on the script real quickly. Let's run the bar plot. So lines 99 and 101. So you can just hit run. Nope, gotta do 99 first. We gotta get that dodge. Then run. All right, do me a favor, go on line 114, Cartesian plot, and let's change that to 1.1. And then change the second number to 1.5. Okay, run it again. Okay, let's go back down to the line 114 and change it to 1.6. From 1.5 to 1.6. Run again. Oh, there we go. Yep. I think those are the type of things that are going to be needed with these data. There's so much variation. It's really disaggregating to ask specific questions. You know, so where are you seeing masculinization in the same water system? Well, this would suggest you're seeing more masculinization in the upstream locations.
I gotta try to do something for this poster that I have to submit on Monday. I'm wondering if I can go back to my spreadsheet. I had, what I don't have in this one is my community with reuse, my Sandoval,
Mhm.
which was this.
This group? Mhm.
So maybe I can get my reuse lakes against,
I think those type of questions are really clean because they're good biological questions. Are we seeing differences in masculinization relative to the use of septic systems versus reuse?
right, and I used, what I did with you just now was golf courses, golf course lakes. What I didn't do was this community in Cape Coral called Sandoval that has water piped to their house and is irrigating probably even more than the golf course.
So when do you have to have this stuff ready by?
It has to be submitted Monday at 5 p.m. Yeah,
Yeah, that's the way of it.
or
So-
yeah,
We're confounding two things at the same time. One, getting the data that you need. Two, trying to teach you some introductory R. R is dense. It's really a valuable tool, but it is dense. If there is a rush for something like Monday, then what would probably make sense is to give very clear, concrete questions that then I could run very quickly so you get that information. And then when we have more time, that's time when then we do exactly what we're doing here.
right.
Walk you through and sort of let you do the coding.
You know, I guess I could use this graph,
Mhm.
right?
Graph
'Cause
says,
this was good data for what it was.
this graph says a lot. I think the other figure that I really like for your narrative is that campus data.
To show how complex.
This is a much more complex system than we might initially want to, describe. Campus is, all of our lakes are supposed to be conservation. They're all supposed to be managed well. But it's very clear that there are certain water bodies which are getting a lot more, the fish are having a much stronger effect in some water bodies than others. And they kind of make sense. The ones by the dorms, the ones by the food forest. I think those say very clear and good information to your all, this story. Thoughts?
I've got a young lady that's done the FGCU golf course or FGCU campus a little bit more, and she did it on her own. So these are her summary table of results. And this is her box and whisker.
Wow.
So
impressive.
with more data points to it.
Mhm.
So definitely, it looks like this is still,
Still showing the same basic pattern.
yeah,
The outlet, the food forest, and North Lake are clearly more masculinized than the rest of the water bodies.
so would it be, maybe I should try to go back to my master spreadsheet. Right now I don't have this is just the septic.
Because remember, this is just Cypress.
Right, and so let me go back to. Do I want to save this?
I would. I think it's going to cause problems again. There's something in those Excel files.
All right,
So get rid of the filter. This is the file that you're working with most recently.
so right now,
Don't do it that way.
yeah,
Make
see,
sure
I
you
don't
select
have
all of it.
reuse on here at all. So
Right.
I never brought over any of my reuse data to the spreadsheet that we've been looking at today. So if I bring over my reuse, I might be able to mess with my code a little
Yep.
and do this same column with reuse.
I would keep it simple. I'd probably do reuse and septic.
All of San Carlos Park against my reuse.
And not campus. I think you got a lot of extra variation in campus. It doesn't make it a true control. My understanding is that campus is supposed to be kind of a control system. It's
We
supposed,
thought it was,
but it's clearly not. You know,
Right.
There's more going on in campus than just a control.
all right, well, I guess, if nothing else, I can use that single image, and then what you're suggesting that perhaps I could just show another image that says the story's more complex. And for example, here's our FGCU campus.
You know, you have a few things, and I mean, one of the biggest observations in your data is that these fish are universally masculinized. I mean, you have that right across everywhere. They're all quite a bit larger than the ratio of 1-to-1. Further, there's a lot of variation among sites. Some of that appears to be how we're managing our use of water. And it appears to be a very localized phenomenon. That's a good story.
All right, I'm gonna go back to my data set, see if I can clean it up enough to get reuse and see what I can do.
Okay.
But if nothing else, I would use these two.
Yes, if you remember how to read and describe slide 12, yep, it says a pretty clear story. And in 11, the most important part is reuse and septic.
Right.
I think campus is more confusing than a single bar represents.
I'm sorry.
Campus has more going on than a single bar.
Right. But so I don't, I'd have to run a different analysis. So I couldn't use this figure.
I'd use a figure, just you're really stressing reuse and septic. I don't,
And then
honestly, wherever the boys figure is again, that shows the campus, and you just had another student show that. I think that actually is a good piece of information. This story is more
Nuance.
precise, more nuanced.
So these two plus the FGCU lakes,
I think so. Yep.
and say, this was supposed to be our control. We
Yes.
started collecting on campus.
And there are some lakes that clearly look like they're good control, but there's also lakes in the same water system where there is a lot of stuff going on.
And I could show, this,
Yep.
but that's got nothing to do with my title.
No, I would keep that one in the back pocket. you know,
The FGCU lake shows the same.
Yep.
All right, well, I'll see if I can clean it up and see what I get. And yeah, bad on me. I decided at the last minute, they had last minute submission possibilities.
good.
And so I did the last minute submission and Lucas Center paid. I just heard yesterday, it's $650 to register for a virtual conference.
That's steep.
Yeah. So if I don't submit something, they don't, they pull me out.
A quick question for you. Do you know how long Cliff is going to be chair?
No. No. Who's gonna, I think he has interest in retiring.
Oh, I'm ready for a new party. I've enjoyed what I'm doing, but I've been doing it for a long time.
Good.
It's time for
I
new.
can ask, we can ask Trey when the term is up. College governance team?
Yep.
I'll see if I can, he's got. That would be really neat. I think he's happy to be done.
I'll talk to him, see what his plans are.
Yeah.
Okay, buddy, I gotta get going. I will post this like I did before. Take me a little while.
Thanks.
Though. All right,
Talk to you later. Bye.
you have a good morning.
Yeah.